All right, so we will give an industry talk at the AU 2020, and we will talk about connecting people and algorithms, generative design for informed decisions. I'll try to just... All right, so my name is Sofia, and I am graduated from Chalmers University of Technology here in Gothenburg, Sweden. I'm an architect and I have a master in urban design and a Bachelor of Science in architecture and engineering. And I also have like a background in programming. So I'm trying to like combine the programming field with the field of architecture. And I'm here with my co-speaker, Eric. He is actually with distance, but in the same room. And our third co-speaker, Anita Appele in Riga, Latvia. So Eric and I, we work as consultants for Bonava, and Anita is employed by Bonava. So Bonava is a residential development company in the Northern Europe, and they have been creating homes and neighborhoods since the 1930s. And they operate in 8 countries around the Baltic Sea. And actually, you can see the spot on the map. Me and Eric, we are here, and Anita is based in Latvia, Riga, over there. So the vision at Bonava is to create happy neighborhoods where people have the highest quality of life. And the mission is to challenge themselves every day to change the housing game, creating better homes and lives for the many. And in order to do that, VDC and virtual construction plays a very important role. So we work a lot with standardization and modularization. We work with something called Bonava parts. So we work with predefined elements, and that could be a wall, for example, and it could be a stair, but it could also be a predefined bathroom as that whole room, or it could be a house. So we work with the Bonava parts, but on different levels, but they are predefined, and we have already all documentations about all of these parts. So the parts are very well defined, but what varies is how they are combined. And that is where generative design comes into the play. So what we want to do at Bonava is to basically flip this workflow, the traditional workflow around. So instead of designing something and then look at what you get in terms of the results, we want to look at the results first and then see what kind of design proposal meet our needs. So we started with single-family housing developments. So Bonava develops single-family housing projects in both Sweden and in Germany. And the houses, as mentioned a little bit before, the houses themselves are predefined and defined as Bonava parts. And that is the perfect prerequisite for generative design. So this is our workflow that we work with at Bonava. So first we have the setup phase, and then we have the generate phase and the evaluate phase, and in the end we have the select phase. And in our presentation at AU 2020, we will guide you through all of these steps, but I'll just do it quite quickly today. So the first phase is about choosing and formalizing rules and constraints. And the setup phase, as I mentioned, we already have the houses. So what we need to define is how they could be combined, how many houses we can have in a row, and yeah, basically rules related to houses. And what remains flexible in this case is the site. So for the setup, we have the Bonava parts, we have the plot, but we also have restrictions and regulations for how the parts can be combined. And we have written an algorithm for shuffling these parts on the site. So for each and every project, we define the site boundaries and we shuffle the parts on the site due to certain restrictions and regulations. And the output is multiple design alternatives. So if we go to the next step, which is the generate step, we can have a quick look at what it looks like. So as mentioned, we develop single-family housing units. And here on the screen, you can see examples of what it could look like when you do that on a neighborhood scale. So here's a project just outside Stockholm where we applied this on. And you can see a lot of different variations for how the houses are combined. So we generate a lot of different options. And in the end, we generate as much as like thousands of design alternatives. And then you can ask, one can ask oneself, like, what do we do with all of these different alternatives? Of course, we need to look at how they are combined or how they are related to each other. So we go into the evaluation step, and each and every alternative end up with a certain profile in terms of data. So in this example, for example, we have 48 houses. We have a certain distribution between A houses and D houses, for example. We have different orientations of the terraces. We have carports. And then for the key values, we have different aspects at the bottom of this page. So another alternative would end up with another profile, and we call it neighborhood profiles. And a third alternative. And we then put all of the alternatives on top of each other, very similar to the generative design tool in Revit 2021. But we are actually not using generative design inside Revit. We are using an external database, and we're using Rhino. So we do the setup and we do the definitions in Revit, but we then push it to a database and explore it in a web browser. So then all of the different disciplines can interact with the data. And one thing, I mean, the topic of our presentation is connecting people and algorithms. So for us, it's really important to emphasize who will make the decisions. If you are a cost calculator, you have certain preferences. And if you work with sales and marketing, you would probably look at other aspects in terms of when it comes to the design. And if you work with procurement, you would look at other aspects. So we basically want all of these disciplines to be connected with each other, and we want to connect them by using algorithms. So the evaluations are in the middle, and then the design team is basically centralized around these kind of evaluations. And in the end, of course, we have a connection to Revit. So the last step is about selecting the alternative. And by just typing in a number, you can import everything to Revit. And because of the standardization and modularization, everything is already predefined. So by just saying, I want alternative 75, you will get all of this documentation into your landscape model directly. And of course, one very important question in this is, how should we think about this? Like, is it an evil robot? Or is it good to have digital assistants? And this is something that we try to tell the design teams every time. Like, we're not trying to reduce the work for the architect or anything like that. We don't want to remove the roles. We want to help the architects. We want to help the design teams. We want them to make data-driven decisions. And we are here and using generative design for informed decisions and for helping people. And we also want to connect people, both by we want to connect people with algorithms, but we also want to use algorithms for connecting people with people. So that's a very short presentation of what we're going to talk about. So if you want to hear more, listen to the full presentation at AU 2020.
Well, I'm intrigued already. That was so interesting. I will say I'm very intrigued by some of your early design process. Are you going to be going over that in your Autodesk University? I don't want to steal from your presentation, but I'm very interested in, before you import to Revit, what that process looks like, if that makes sense.
Oh, you mean the process itself, or?
Yeah, like what type of computer programs are you using? You said you're a programmer. What type of code are you using? Those types of things.
All right. Basically, we're using Rhino and Grasshopper for using the geometrical engine that they have developed. So we do the definitions of all of the parts. That is defined in Revit. But we then extract information from Revit. We import that to Rhino, and we use Grasshopper for shuffling the parts We are then using a database called MongoDB. So we take the necessary information from Rhino, push that to MongoDB, and then we have a front end connected to that. So if you then type in like, I want alternative 75, we already know, okay, family type, we know position, we know vector, we know the necessary information for the Revit part basically. So when you type that in, you kind of recreate the alternatives inside Revit, if that makes sense.
That's fascinating. Have you looked into Rhino Inside at all?
Yeah, we're actually using Rhino inside of it.
Awesome. And we do have a question from Jean Robinson, that's wondering, will you be discussing how to generate the algorithms within your presentation?
Yes, for sure, we are.
So we'll have to check it out. We'll just have to make sure we check out that presentation. Well, thank you so much, Sofia. And we're definitely looking forward to that.